Did you ever figure out that code for that?
Yeah. Yeah, and a bunch of people saw it. Yeah. That's like there was no context at all either. It was just like there. Like people, I was like, what were people thinking? Like,
Did anyone
what did she just post? Like,
Did anyone fight?
no, it was just like they just. I don't even know. No, because there are some people that genuinely post stuff like that. And so they probably just like scrolling through it.
Can you go back to that window, yeah.
I hear you. After we get that through with 4.2. Sure.
That is my Latin back.
Okay, the first thing that I want to go over with you from the unit circle is how they get your X and Y coordinates that relate to all of your 30-degree angles that are inside each quadrant. So notice that this angle here is 30 degrees above the 180 degree or pi angle. This angle, of course, is 30 degrees into quadrant 3. And they use special right triangles, which we talked about in 4.3, to get that. So recall the relationship between the short leg, long leg, or hypotenuse in a 30, 60, 90 right triangle. Short leg, they let be represented by 1. You get your long leg by multiplying that by √3. Hypotenuse is always double that. So in a unit circle, unit means it has a radius of what? What number is associated with unit in math? 1. Okay. So in a unit circle, your radius length is 1. So from any point from the center of the circle to any point on the circle has length 1. If you know or memorize your first quadrant information, then you can just go straight across into the second, diagonally into the third, straight down into the fourth quadrant, and you'll have the same X and Y coordinates, maybe different signs depending on where you're at. All right, so if we zoom in to the first quadrant, draw a 30-degree angle, and we want to find out what that X and Y values associated with the coordinates are. Remember that 30 degrees is the same thing as pi over 6 in radians. Your radius length is 1, so that is actually your hypotenuse. The hypotenuse was always double your short leg in a 30, 60, 90, meaning that short leg is half of that. So that's how they get this Y coordinate of 1/2. How they get what your X coordinate is, they take the short leg and multiply it by √3. So √3/2. Now, in a unit circle, if you start out with that very basic 30-degree angle, you can, of course, just keep rotating 30 more degrees. So that would be your 60-degree angle. So, and the way you can do it in radians, people always are like, the radian measure throws people off. So if you say 1 pi over 6, 2 pi over 6, or pi over 3, 3 pi over 6, which is pi over 2, and then you go 30 more degrees, 3 pi over 6, and this was 4 pi over 6 or 2 pi over 3. And then 5 pi over 6, 6 pi over 6, which makes pi, 7 pi over 6. And then this would be 8 pi over 6, 9 pi over 6, 10 pi over 6. And so you guys get the picture. But all you have to do, the reason that I showed you, I don't know if you guys looked at the 4.2 unit circle project that I created before Christmas break, around Thanksgiving, before the cyber thing. But I was showing you how to draw a line from this angle straight across to that one, straight down, straight across, and then highlight those in a different color. And the reason is, once again, their X and Y coordinates are the same, but may have different signs. So if you remember that pi over 6 is root 3 over 2, 1/2, then every pi over 6 angle in each quadrant will have root 3 over 2, 1/2, positive or negative. Okay, if you look at the 60-degree, pi over 3, all your pi over 3s in every quadrant, the way they get your X and Y, this is a 30, 60, 90. You know that your radius length is 1. That's your hypotenuse. This is your short leg this time. So that's why X is 1/2. This Y value represents your long leg, and that's short leg times root 3. So root 3 over 2. So pi over 3, 1/2 will be first, switches around those coordinates. What? What'd you say?
Different. Wait, this.
All right, last one. Your 45-degree angles that are in every quadrant halfway through. Notice that they go 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So they go by odds. And the reason is, if you went by 45 degrees, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, so on. And remember that in a 45, 45, 90 special right triangle, your leg lengths are equal. So we'll let this be your radius length again of 1. The relationship that your short, or that both your legs have to your hypotenuse is you divide your hypotenuse by root 2 to get any leg length. And so, of course, if you rationalize that, you get root 2 over 2, and that will be both your X and Y coordinate for all of your pi over 4 angles. And if you're in quadrant 2, of course, your X is negative, Y is positive. Quadrant 3, both your X and Y are negative. Quadrant 4, X positive, Y negative. All right, so hopefully that was a very quick rundown of how they obtain your X and Y coordinates. Now, how you actually use your unit circle in 4.2, every X coordinate of the angle will give you your cosine value. So cosine, if I'm asking you what cosine of 30 degrees is, cosine of pi over 6, you look at the X coordinate associated with that angle, that's your cosine value. Sine value is your Y coordinate, sine Y, cosine X, cosine X. Cosine X, sine Y. Tangent, you're not going to like tangent at all in chapter 4 or 5 because you have to do, tangent is always extra work. You'll see a lot of complex fractions in this unit and the next one. Tangent is obtained by taking your Y coordinate, putting it over your X coordinate, and simplifying. Or you can take your sine value and put it over your cosine value. So notice on your unit circle, I've already went around and calculated all of your tangent values for you. That's what you see out to the side. So if you'll notice that pi over 2 or 90 degrees at the top, your ordered pair associated with it is 0, 1. To find the tangent, you take and set 1 over 0, and so that's why tangent is undefined at 90 degrees. Tangent is also undefined at 270. Okay, another thing I want to point out here, I see this a lot every year. If you're telling me what the tangent of pi over 2 is, you're not going to say tangent undefined. Like, people want to keep bringing down tangent. This is not it. You just tell me it's undefined. That's all you're going to do. Drop, sine, cosine, tangent. Okay, since your X and Y are both positive in the first quadrant, all trig function values will be positive. And I'm showing, you may see this a lot, your angles represented in inequality form. So an angle that lies in the first quadrant, of course, is going to be less than 90 degrees, but it's going to be greater than 0. In quadrant 2, your X coordinate is negative, Y is positive. Since Y is associated with sine, sine is the only positive trig function in quadrant 2, as well as its inverse of cosecant. So cosecant and sine will be positive. An angle that is in this quadrant is less than pi, but it's greater than pi over 2. In third quadrant, tangent is the only positive trig function as well as cotangent. Your X and Y are both negative. So to get Y divided by X for tangent, it'll give you a positive value. But sine will be negative and cosine will be negative. All right, in quadrant 4, cosine is the only one that's positive because your X is positive, but your Y is negative, which means sine will be negative. And secant, cosine's inverse, is also positive. So an angle in this quadrant is going to be less than 2 pi, but it's going to be greater than 3 pi over 2. Okay, let's say in a circle, you've got some angle that's been rotated to this point, and it has coordinates negative root 2 over 2, root 2 over 2. This is the very first one that you encountered in 4.2. So they give you an X and Y, and then they ask you to find all 6 trig values for T. Okay, so you just learned that your sine value in an ordered pair comes from which one? Sine is associated with what? Sine is your Y value. So sine is going to be positive root 2 over 2. Your cosine value in an ordered pair is your X coordinate. So that's going to be negative root 2 over 2. To get your tangent, you set your Y value over your X. If you have the same thing over itself, what do you get? Good, you get 1. So this is going to be negative 1. All right, now go back and find cosecant of T. So you're going to flip sine. And rationalize that. So you get 2 root 2 over 2, which simplifies to root 2. Okay, since my sine and cosine were the same but different signs, then tell me what you think secant will be. Cosecant and secant have to be the same thing except for different signs. So that'll be negative root 2. Not always. In this case, they are. Notice how sine and cosine were both √2/2. This one was negative. So you can always, if that's the case, you can always assume the same thing for their inverses. All right, cotangent, if you flip -1, you get -1. Okay, does that problem make more sense now? What?
It was just a lot of work. I was finally got to do that.
Yeah. Okay, the next thing that we're gonna do is practice using our unit circle to get trig values. So make sure you're referring to that. All right, use your unit circle to find trig values. Leave your answer exact unless they tell you otherwise. So in number 1, we have the tangent of 0 pi. Tangent of 0 pi. Remember to find tangent, you take your y and divide it by your x. What do y'all think tangent of 0 degrees or 0 pi is? 0, good. Your ordered pair associated with that point or with that angle is 1, 0. So 0 divided by 1, 0. Okay, number 2. Let's find the secant of 11 pi over 6. Secant of 11 pi over 6. You need to find what and flip it. What is secant's inverse? Which of the basic 3 is secant's inverse? Cosine. So let's find the cosine of 11 pi over 6. So look at your order pair at that angle. Give me the x coordinate. √3/2. So this is equal to √3/2, but in order to get the secant of 11 pi over 6, I take that and flip it. So when you rationalize, you get 2 √3/3. Okay, are y'all, how do y'all feel about this? Yay, nay? Comfortable? Okay. All right, let's look at a negative angle. Sine of negative 5 pi over 6. Okay, if you are starting, you remember in any angle, we learned in 4.1, you start on the positive x-axis. This is a negative angle, so I've got to rotate clockwise. Pi over 6 is 30 degrees. So all you have to do is pick out what your basic angle is, pi over 6, and you're going to go 5 times in the negative direction. So here's 1, -1 pi over 6. Rotate 31 degrees, -2 pi over 6. 30 more degrees, -4 pi over 6. 30 more degrees, negative 5 pi over 6. That'd be negative 4 pi over 6. And then 31 degrees, 5. But I want you guys to notice something. Look, 5 pi over 6 in the positive direction is 1 quadrant and 3/4 of another. So 1 quadrant and here. So if you rotate in the same direction, 5 pi over 6 is going to be this angle. Like, you just kind of have to flip it and transpose it in your mind, if that makes sense. So 7 pi over 6 and negative 5 pi over 6 are the same angle. What is your sine value? Find 7 pi over 6. Tell me what your sine value is. Negative 1/2. Cotangent of negative 3 pi over 2. So notice in the positive direction, 3 pi over 2 was 3 complete quadrants. So if you're going in the negative direction starting here, you go 1 quadrant, 2, 3. So pi over 2 and negative 3 pi over 2 are the same angle. They're coterminal angles that we talked about in 4.1. What is your cotangent value there? If your tangent is undefined, then cotangent will be defined. Look, okay, I'll help you out. Tangent, you know, was y over x. So that means that cotangent is what? There you go, x over y. So if you set the ordered pair that was associated with negative 3 pi over 2 or pi over 2, 0, 1, you've got 0 is your x, 1 is your y. Whenever 0 is on top, it's 0. Wherever tangent is undefined, cotangent will be 0, and vice versa. Wherever tangent is undefined, well, no, that's what I just said. Wherever tangent is 0, cotangent will be undefined. Does that make sense or no?
No.
Okay. All right, look at all of your quadrantal angles. So you have 0 degrees and 360, which are the same, they have the same order pair. 90 degrees at the top, 270 at the bottom, 180 out to the left. Okay, if we look at this angle, tangent is y over x, so 0 over 1 will give you 0. But if you're finding the cotangent and reversing that, you've got 1 divided by 0. And you can't have that. Can't have 0 on the bottom, it's undefined. So cotangent of 0 degrees or 2 pi would be undefined, but the tangent value is 0. Same thing at the top and the bottom. If you're finding tangent, that's y over x. So that's undefined. But if you were to reverse it and find cotangent, you're setting your x over y. 0 divided by 1 will give you 0. Okay, does that make sense? All right, number 5. Okay, the sine of 4 pi. Sine of 4 pi. Okay, a complete revolution around the unit circle is what? In terms of pi. It's 2 pi. And so if we just go around one more rotation in the positive direction, go around one more rotation, then you're gonna be at the same angle. What is your sine value there? What's your y coordinate? 0. They're not always 0, like a lot of them we've gotten out of that. Okay, cosecant of 4 pi over 3. Cosecant of 4 pi over 3. Okay, 4 pi over 3 is here. Cosecant, you need to find what basic trig function first. It's always opposite of what you think. Cosecant and sine go together. Sine and cosecant go together. Or cosine and secant go together. So cosecant, we need to find sine first. Tell me what the sine of 4 pi over 3 is. Your sine is your y coordinate. So negative root 3 over 2. Okay, then you take that and flip it to get your cosecant value. So this will be negative 2 over root 3. You have to rationalize. So you get negative 2 root 3 over 3. Okay, y'all need to tell me if you're really making that great of an effort on this, how well you understanding the circle.
Not at all.
Okay, are you paying attention or are you working on Latin though?
I thought we're going to
Okay.
I get
Okay, the easiest way I'm going to tell you is you've got to find whatever angle they give you. That's your first part. So 4 pi over 3, all you have to do is look at your unit circle. It's in that bottom quadrant here. All of your sine, cosine, tangent, whatever values, all of your answers are going to come from the x and y ordered pair that they give you associated with that angle. If you are asked to find secant, if you're asked to find secant of any angle, you need to find the cosine of that angle and flip it. If you're asked to find secant of any angle, you find the cosine value, which is your what? Cosine is associated with which coordinate? X. So this is your x coordinate, and then you flip it and simplify it. If you're asked to find the cosecant of any angle, you find the sine of that angle and flip it. Sine is your y coordinate. Cotangent of any angle, you find the tangent value. Well, you'll tell you what's going to be the easiest, bless you, it's going to be the easiest thing for cotangents. All right, cotangent, you can set your x coordinates over your y coordinate and simplify it. So cotangent, take your x, put it over your y and simplify it, or it is tangent flipped. Either way you want to think about it. What? Yeah. Okay, if they ask you to find cosine, all you do is find your angle and look at your x coordinate. That's there for you. Find sine of any angle, locate the angle, look at your y coordinate. Okay, tell me what the cosine of 7 pi over 4 is. And another way that you can easily find this angle, rather than having to look at all of them at one time, notice that 7 divided by 4, that is really close to what? That's really close to 2 pi. So this is going to be in quadrant 4. And so you just look at your x coordinate, good, which is root 2 over 2. Okay, let's look at the secant of 7 pi over 6. 7/6 is right past 1, like it's 1.0 something or 1 point, I don't know. So 7/6 is right past 1 pi. Notice that you find 1 pi here, so 7/6 must be past that in quadrant 3. So 7 pi over 6, you're asked to find secant, so what do you find first? Sine, cosine, or tangent? Good, you find cosine first. What is the x coordinate for 7 pi over 6? Okay, so let's take that and flip it. When you rationalize, that gives you -2 root 3 over 3. That's why I wanted you to get some more practice with 4.2, because a lot of your problems are just like this, like what's the cosine of 7 pi over 4, what's secant of 7 pi over 6, and it's just getting you familiar with using your unit circle information. Okay, number 9. Let's do cosecant of 9 pi over 4. In these angles, you always need to try to think about, okay, 9/4 pi is that, what quadrant would I be in? Is it greater than 2 pi? 9/4 is definitely greater than 2 pi. 9/4 is what? What? Okay, so 9/4 is 2 pi and 1/4 pi, or 2.25 pi. So for this angle, you've got to go completely around your unit circle. So you're going to go all the way here to 2 pi, and then how much more do you have left? You've only got 1/4. So go all the way around to 2 pi. You've got 1/4 pi left, which would be at this positive 45-degree angle. So 9 pi fourths is the same thing as just pi over 4. Those are coterminal angles. In order to find cosecant, you first need to find what? Sine, cosine, and tangent. Sine. What is the sine of pi over 4? Good. Sine is root 2 over 2, but you flip that to get cosecant. Rationalize is going to give you 2 root 2 over 2, which will simplify the 2. Okay, do y'all feel any better about it? Okay. I did, and the only reason is you don't have to do it that way. You don't have to do it that way. You could just say that 9/4 is 2.25 pi. The whole point I'm trying to make is just to get you to see that this is a whole rotation of 2 pi. Like it's going to be more than 2 pi.
When When do we start combining that?
Yeah, no, just don't pay any attention to that. So 2.25,
Just trying to make it so you can see that.
yeah. Does that make sense, Cooper? What he's saying? Like he was saying, I was trying to show you that it's greater than 2.5, so you have to go completely around, and you were left with what? 9/4 is 2.25, so you're left with a fourth or 0.25, which would bring you here. Okay. For the next top, I don't know what number is this? Are you am keeping up with it? No. Yeah. Okay, for this angle, when they present it to you in this very complicated looking form, you've got this basic angle of -pi/4, which would be, of course, rotated from this positive x-axis down into the fourth quadrant here. So this is your -pi/4 angle. Tell me what angle on the unit circle is associated with that? -pi/4 or what? What is the positive angle that's there? Good. So, or 7pi/4. So 7pi/4 and -pi/4 are coterminal angles. Your ordered pair is √2/2, -√2/2. Okay, anyway, so we've got this basic angle. Then they say I'm subtracting 1,000 pi from that. If you ever see a problem like this, see if this number is a multiple of 2. Is it? Is 1,000 a multiple of 2? Yes. So 1,000 pi, how many revolutions would that be? How many times will 2 pi go into 1,000 pi? 500. So this is actually just 500 revolutions around. That's all that represents. So really, if you rotate here, and then you keep going back around and around and around and around 500 times, you're going to be at the same angle. So 1,000 pi does not even matter, because all it's going to do is bring you back around. So I'm going to rotate here, but then I'm going to keep going around and around and around and around 500 times. Does that make sense? Yeah, no. Okay, that was like a kindergarten. But cosine, so now that I figured out, this is just going to bring me back around to the same angle. All you're telling me is what the cosine of -pi/4 or 7pi/4 is. What's your x value? So the cosine of -pi/4 minus 1,000 pi is √2/2. Okay, number 11. You've got negative cotangent of pi/4 plus 17 pi. Start at your basic angle . So your basic angle is pi/4. So that will be positive in the first quadrant here. Okay, you have to figure out, so we rotated here and this is where we're at. If we add 17 pi how many rotations is in that? It's definitely not a multiple of 2, but how many rotations would be in this? Good. You've got 8 rotations, which would bring you 8 rotations would be equal to what? 16 what? 16 pi. So then where does a rotation of pi take you? Good, it takes you halfway around. So then you've got a half rotation left, which would be pi. Okay, so if we go around, so I'm here, and you're gonna rotate completely around back to the same angle 8 times. So let's say I rotate around 8 times. Where would a half rotation take you? It wouldn't take you, good, it would take you into this. A half rotation always takes you 2 quadrants over. So I'm here, I'm gonna rotate halfway around this circle to this angle, which would be 225 or 5 pi over 4. So started at pi over 4, this is where you end up after adding 17 pi. Does that make sense? Okay, I hope everybody that's on your phone like the whole time. I hope, okay with that. What's your cosine? I mean, so we're looking for a cotangent. So this will be negative root 2 over 2, negative root 2 over 2. Your tangent value at all pi over 4s, pi over 4 angles, your tangent is easy because you have the same y, same x. So tangent is 1 or negative 1. They ask you to notice that you're asked to find negative cotangent. So if my tangent value at this angle is positive 1, then what would your negative cotangent value be? Negative 1. Tangent, your cotangent and tangent are both going to be positive 1. But since they put the negative sign, like in your problem, in front of that, like this part, does that make sense? Like this part here would be positive 1. Yeah, tangent and cotangent are the only trig functions positive in the third quadrant. All right, now that we have looked at how to use the unit circle, we need to look at, there's identities that are very important that you know them. Okay, you can write these down, or I've posted the notes already in Schoology. In 4.2, they introduce very fundamental trig identities that you will use all in chapter 4 and in chapter 5. If you will memorize these, it's going to greatly help you, and it will, anyway, you can work through your problems quicker, especially when we get to chapter 5 and we start proving identities and manipulating problems. If you plan on taking calculus, you'll have to use trig identities a lot in calculus. Right. AB. All right, your very basic trig identities from the unit circle, which we've already talked about. Sine was associated with your x coordinate, cosine y, tangent was y over x, and of course to get your cosecant, secant, cotangent, you just flip those. Okay, a long time ago in section 1.8, we talked about inverse function, even odd function. Your only even function, which when we graph these later on in chapter 4, you're going to see that the cosine graph and its inverse secant are the only graphs that are symmetric with the y-axis. So that's another key that is even. So what an even function says is that even function identity, cosine of any negative angle will come out to equal the cosine value of the positive angle. So that's saying, for example, if I have the cosine of negative 30 degrees, it has to be equal to the cosine of positive 30 degrees. And if you look at your unit circle, cosine of positive 30 degrees is root 3 over 2. And the cosine of negative 30 degrees, which is associated with 11 pi over 6, is also root 3 over 2. And same thing, so cosine and its inverse secant are the only even functions. Secant of a negative angle comes out to be secant of that positive angle. Odd functions are sine and tangent, and their inverse is cosecant and cotangent, saying that sine of any negative angle will come out to be the opposite of the sine of the positive angle. So sine of negative 30 degrees will come out to be the opposite of sine of 30 degrees. What's the sine of 30? 1 over 2. So this will be negative 1/2. Sine of negative 30 degrees, if you rotate into the fourth quadrant and look at 11 pi over 6, you get negative 1/2. This is sine of negative 30. So cotangent of negative pi over 3 would have to come out to be negative cotangent of pi over 3. Okay, your reciprocal identities you're already familiar with. Sine, you can flip 1 over cosecant to get sine. Same thing with cosecant. You can flip that 1 over sine to get cosecant. Later on in chapter 4 and 5, you will use these identities. In some of your problems, before you even start working it, you will need to substitute in cosine for 1 over secant if you have it in your problem. Or sometimes you might want to plug in 1 over cotangent for tangent. So that's why these identities are important. Okay, quotient identities. Very important that you know tangent equals sine over cosine, and cotangent will equal cosine over sine. This is one of the most profound trig identities that you will see and one of the most widely used. Sine squared or sine theta squared plus cosine theta squared of the same angle will always equal 1. Always. So if you've got the sine of 30 degrees, which we said is 1/2, and you square that, plus the cosine of 30 degrees, square that, it should come out to equal 1. Sine of 30, where you said was 1/2. So we'll have 1/2 squared. Cosine of 30 degrees is root 3 over 2 squared. Square both of those, 1/4 plus 3/4. 1/4 plus 3/4 equals 1. So if you see sine squared, cosine squared, tangent squared, all it means is you're taking that x or y coordinate and squaring it. The identities in blue are just different forms that you will also see that follow from the basic 3 Pythagorean identities. So another version that you will use, cosine squared is equal to 1 minus sine squared. sine squared is equal to 1 minus cosine squared. Sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. I've seen an ACT question ask that. It asks you to graph this. Asks you to graph this function like y equals sine squared plus cosine squared of x. And if you don't know that's 1, you wouldn't be looking for a simple horizontal line going through the y-axis at 1. So definitely, if you don't remember any other version of it, definitely remember that one. This one is also very common. 1 plus tangent squared of any angle will equal secant squared. And 1 plus cotangent squared equals cosecant squared. Once again, in blue, different versions that you'll see. Okay, another thing, if you see sine of an angle plus cosine of an angle, that is not equal to 1. It must be squared, has to be squared. So make sure you pay attention to that. You can't say 1 plus tangent theta equals secant theta. Not possible. It only works if they are squared. All right, where that comes into play, you've got some problems in 4.2. They're going to give you a sine value or cosine value, either one. So sine of t is root 39 over 8. They ask you to find cosine of t using those identities. So you have to look back at your list of identities, find one that relates sine and cosine only. And the only one that you can find is sine squared of that angle t plus cosine squared of t should equal 1. You've got, of course, tangent is equal to sine and cosine, but you don't know what tangent is. Okay, so plug in root 39 over 8 for sine, and what are you going to do with that? It's got to be what? It does have to be subtracted, and it's got to be squared. So sine of t squared plus cosine squared t okay, when you square this, it's going to give you 39 over 64, and then subtract it from this side. If you find a common denominator, 1 turns into 64 over 64. And this will give you 25 over 64. Now, how would you just get cosine of t? Tell me what your last step is. Good. So you square root both sides, and you're left with cosine t equals 5/8. They also give you some very easy problems, but if you don't know your identities and don't know what to do with them, you're going to be lost. It says use identities to find the value of each expression. They give you this: sine squared pi over 6 plus cosine squared of pi over 6. And they want you to find out what that's equal to. Sine squared plus cosine squared of the same angle is always equal to what? Good. 1. You don't have to do any work. Now, if you don't know that identity, you can find the sine of pi over 6, cosine of pi over 6, square them and add them. But if you'll remember that identity, you don't have to do any work. Another one that you'll see is like cosine of 2.3 times the secant of 2.3. cosine and secant are what? They are what to each other? Yeah, and they're opposite, they're inverses. So cosine of 2.3 times, and you can change secant of 2.3 to become 1 over cosine of 2.3. And so all that cancels, you're left with 1. So anytime you see sine, cosine, or tangent of the angle multiplied by its inverse of the same angle, it's always 1. Now, I'm not gonna work through this last one unless you just need me to. Because the first example that we did is very similar to it. You also have a problem in 4.2. It's gonna give you your sine value. It's gonna give you a cosine value. And it's gonna ask you to use identities to find the other 4 trig functions. Well, if you know sine and cosine, you can get cosecant and secant by doing what? Good, flipping. How would you get tangent? Tangent is sine, good, over your cosine value. So then you would just flip this fraction, multiply it to 1/3. Simplify that and then flip it to get cotangent. Okay, so working on your 4.2 stuff. What? Really fine. You're just not feeling it at all today, are you?
This class is probably better than the regular class, if I'm being honest.
This is your
Yes, you'll
What
be
if I ran
fine.
like just cried? Did they?
It really, I don't,
Like I've already done half a year. So it's like,
you should just tough it out.
yes, like almost done, and then I'll have my 4 and things credit. And I'll take Spanish will take it.
Just tough it out, you'll be fine. I know you guys are ready for school to be out. What?
I'm ready to get back to.
Hey, yes.